Perfect. Thank you, Azam. So for everyone who is attending the call, and for those of you who will be going through the recording later, just to let you know, this is our last session before our break. So we'll be taking a break in December and then restarting our training sessions in January. And Azam will be walking us through some very interesting things today. Before he starts, I'll just like to give you a little couple of updates. So, as you know, we've set up the pre-processing, neuroimaging, and AI lab at King Saud University at the girls' campus. And inshallah, next weekend, we will be finalizing the setup of the machines, and hopefully they will be then active and available for everyone to log in. You'll be able to take advantage of the high-end hardware and software capabilities of those machines. You'll be able to log in remotely, and it'll really help you in terms of data processing and neuro and pre-processing in neuroimaging. So that is one big positive that we are all very excited about. So that is one thing. And on a side note, I will inshallah be visiting Riyadh now. Probably I have some visa regulations I have to fulfill, but hopefully, inshallah, I will be visiting Riyadh, if not late December, then in early January, because we've got some MOUs in the pipeline over there, and we're just waiting for stuff to get finalized. And I will hand it over to Azam so that he can start with today's presentation. Azam, please go ahead.
Um, okay, Ahmad bhai. Today I am explaining about something about the narrow imaging, how the narrow imaging interact with LLM models, and especially the lecture is designed from the state-of-the-art medical LLM named as MedGemma 3. The MedGemma 3 is a LLM model designed by Google, and especially the model interpreted the images and also the
Azam, sorry to cut you. I see two of Dr. Schwag's students have joined in, Razan and Raneem. So, girls, for your information, my tech team will be going to King Saud University to the AI lab next week. So we've gotten, well, first we were not able to get permission to enter the campus because it's a girls' campus and the networking team were all boys. But now we got permission, and I've got the gate pass that I forwarded to the tech team. So next Saturday, not tomorrow, Saturday week. So next Saturday, the technicians will be going there and they will sort out the issue with the connectivity issue with the internet and everything, and they will get the machines going. So once the machines are get going, Azam will give you credentials to so that you can access the machine online, and then you'll be able to see all the software and everything. As you guys probably know, Dr. Schwag was away at a conference for the last couple of weeks, but I have just spoken to her 2 or 3 days ago, and now she is back. In fact, I think some of you were actually with her, and congratulations on your great achievement over there. So, inshallah, we will get this. The machines are installed and everything, just the internet issue we have to. You're most welcome, Ranim and Razan. The internet issue we have to resolve. Now, you have to understand what the issue was that King Saud University were not able to give us access to the machines because they said that their network is closed and they don't want any external parties gaining access to it. So there was no way we could connect to it. But we'll sort it out. We'll get our own internet and we will get those machines running so that you guys can not only physically use them when you're at the campus, but you can also use them when you're at home. So you can remotely log in, and I'm very impatient and super excited about it because I want to get it going quickly because then you can actually use the software and physically do everything. Because I know we have these sessions and we train you, but you physically have to do it. So practically doing it is the best way to learn all that stuff. So today is the last session before our break. We will be taking a break of 1 month. So in December, because there's holidays and exams and people are traveling, we will reconvene in January. But for you guys, Dr. Schwag students, as soon as the lab is set up on next Saturday, inshallah, Azam will be in touch. He will share all the details with you. And if you guys are available, we can have maybe a short 30-minute session every week where we can walk you through it. And we will be available throughout December. Even if officially the training session is not taking place for a month, we will still be available for you. And if anyone wants to you start using the machines and start the pre-processing stuff, I think you will find it very exciting. Inshallah, I'm looking forward to it. So back to you, Azam. Thank you.
Okay, thanks. Now, the today's lecture is about the LLM models regarding the medical point of view. Today, I am discussing about two things. First thing is the LLM models, MedGemma. MedGemma is a product of Google, and it's a state-of-the-art model for the interpretation of MRIs, fMRIs, X-rays, CT scans, and other diseases like brain tumor, skin diseases, and other clinical reasoning. Uh, the accuracy claimed by Google is around about 90 plus accuracy given such model. And the one capability of the model is that you also fine tune this model according to your perspective. I also fine tuning such model in future for Alzheimer point of view, and also the model is capable for providing the right accuracy regarding the Alzheimer disease. Now you see that the MedGemma 3 version is also available in the Google website. It is open source model, and you fully locally deploy on your machines, and you also use search model from Google Cloud and other clouds which are available. But the reason is that the clouds are not free of cost providing the MedGemma model, but you work on such model locally on your machine by applying some LLM models locally using Olama. In next lecture, when we are starting about in detail in LLMs, how the LLM install locally and how you can deploy some other open source models in your local machine. Especially the need for local machine for running the LLM model is that the machine must have GPU. And in our lab, we also install the Series 5 GPUs in our both machines. And the minimum requirement for running the LLM is Series 4 GPUs. And our series is latest series because now at this time, the 50 series is too much hot series for NVIDIA for running the LLMs and other graphical and data processing tasks. Now, let's start about what is MedGemma and what is the capabilities of the MedGemmas. As you see that the key features of the MedGemma is that first feature is that medical image analysis. You give an image, any type of image, JPEG, PNG file, BMP file, any format of image. You upload the image, provide some image, the model understands some sub image and interpret the image according to your requirement. Because when you upload the image, you also give us a small prompt regarding the image. Just like that, when you upload the image, you also interpret that the interpret and diagnose such image, specifically the question regarding the task which are you are providing from the LLM. And according to your task, the LLM interpreted the image for your or on library and track some other tools. And the second feature is text summarization. Text summarization means when you have a medical record of some person, just like that, if I have a medical history, just like a blood report, yeah, just like some other reports regarding the patient's specific disease, the model also interpret the reports according textual reports according to the nearly uh, accuracy, proper accuracy regarding the doctor interprets such like reports. And the most important feature in this model is that the medical question answering is just like the answering you are answer the report like communicate like some radiologists, some doctors, some special surgeon. The model, when you interpret as a chatbot reply all the question in sense of the professionals. And this last thing is open source. Open source is one of the most important thing because many models are not open source, but most of the models of Google are open source, and the MedGemma is one of them. Now we move forward. How we apply such MedGemma from our needs and our scenario, because I am also implementing our model from such
So Azam,
scenario.
uh, Azam, I'm going to add something before you move on. So just to quickly summarize what Azam said back there, what happens is you go and you upload one of your pictures, one of your images to MedGemma, and then MedGemma does the complete analysis and it gives you results. So in the results, it'll give you a written explanation. It may give you charts and graphs. It may give you imagery, which will be illustrative and illustrations that'll help you understand what the explanation is. And this is also a part of our main product, the NCAI model that we're building. So what it does is once the pre-processing stuff is done, then that image gets sent over to MedGemma because that's the LLM, medical LLM that we use at the back end. And this is a large language learning model, which is specifically for the medical sciences. So it has a lot of information in it, and then the correct information is fetched and it is given to the user. So I'm just telling you in easier words as a summary. Azam, please continue. Thank you.
Okay. You see such diagram in the upper part. We can interact over MedGemma because the MedGemma is in the variant like 37 billion variant from textual data, and also the image and textual variant is 27 billion plus 4 billion images. And I interact our model and tune our model for multi-model of 37 billion textual data and plus 4 billion images. Now, MedGemma also interact from medical text and also FHIR. It's means the health records of the hospital, federal hospital health record, and also the medical imaging. The medical imaging supported that radiology image, in radiology, all type of radiology like neuroradiology, like your body scan and other things which are also covering by radiology, and in also is also interpreted dermatology means skin diseases, and also the digital pathology. Digital pathologies mean your reports or blood reports, your report regarding the lungs, liver, and other things. And other thing is ophthalmology. These are also a line of medical imaging. And the plus point is that you also add your um, own images and own textual data and all the library in the MedGemma during the fine tuning of the MedGemma, but it is required a high source of computing and some routines of work which are very important from the learning of the LLMs. And the other thing is that rather than you are embedding from medical images, you also add some other models, yeah, other LLM for such model. You see that the first is MedGemma, and MedGemma also interact the MedSlip. MedSign Lips is also a LLM model from Google, but the accuracy of such model is not too much good. You see that zero point 0.4 billions parameters are designed from such MedSlip. But in our case, when we design our product, in case of MedSleep, we also embed our model like narrow Alzheimer model from the imputation of our models. And you also embed
So,
some other.
Azam, sorry, Azam, I have a question for you. If we are training our own model, the NCI model, it is all obviously being trained on alpha detection of Alzheimer's disease, and we're using MRI, fMRI, and tau and amyloid PET scans as well in terms of data for the data training set. What I'm thinking is just to clarify, excuse me, just to clarify for the students. So if we get hospital records for, let's say, 20,000 people, okay, who are
Yeah,
Alzheimer's patients, or 10,000 people, let's say, and we train a model on that, are we also able to add that hospital data for those 10,000 patients to this and then train this as well?
yeah. You see that we have FHIR records. FHIR record also means that the hospital records. We also include our model the hospital records, and the hospital records also have the previous history of the Alzheimer and other diseases of the patients. And the it's also a part of MedGemma infection. But I explained that we also trained our model like the medical image specific for Alzheimer's, because these models are not specifically recommended for Alzheimer because it is a multi-model. It's cover many things, but we also train them, fine-tune the things according to our need. This is specificity of the model of MedGemma, and MedGemma provides you the your code for the fine tuning of model. And this is the specificity. You can add any other things. You cannot build the LLM from the scratch, because the from the scratch it is not easy to build a model from a scratch, specifically the billions of parameters. You need too much high computing, but the model has the flexibility. You add some portions according to your need and embed that. That's the point. Okay, I move
Okay,
forward.
thank you. Thank you. I got it. I'm just going to add one more point over here. So this is for everyone's benefit who is interested in the NCAI product. So the product that we're building, obviously, it will help doctors diagnose Alzheimer's disease, and the process is simple. They take a simple MRI or fMRI and they upload it to our system. Our system runs it and then gives them the result. You've seen for those of you who've seen our first diagnostic Alzheimer's diagnostic report, you know what I'm talking about. But what I would also like to add over here, although Azam will probably talk more about it in upcoming training sessions, but I'm just excited to share it with you guys, so I want to tell you. So once the our product is ready, what capability it will also have is that the doctor, once they upload the fMRI and get the first Alzheimer's diagnostic report, they can also then have a conversation and they can interact with the model. So, for example, they'll have all the hospital records for the patient already in the system, and they have an option to do that. And now they have the Alzheimer's diagnostic report, which the system has generated. Now the doctor can ask questions from the model that, okay, this patient had a fMRI done 2 years ago. Please compare this portion of the fMRI to the fMRI that has just been conducted recently, and they can also ask specific questions like how much is the regression on the hippocampus, and so on and so forth. And the model will then answer all those questions. So it will make life a lot easier for doctors and people who are using this model. And this is also a very, very exciting feature of it. So I just wanted to let you guys know. And thank you, Azam. Back to you.
Okay. Now the specificity of MedGemma for other medical models. First is that the MedGemma is open source, because the other models, medical model, are not open source. Google MedSlip is also an open source model, but their perfection and accuracy is not up to the mark. The first version of MedGemma is MedGemma 1.0, then moved to 2.0, and the coming version is 3.0. And the other thing is that some models are also trained on images, but not too much images. But the main thing for the specialty and advantage of such model is that the model is also trained 27 billion textual data and also 4 billion images data nowadays, and in the future it may be more than like 7 to 8 billions of images. And the some limitation is that need some clinical validation, because all the AI models are not the end results, because the it just facilitates the doctor, and it needs some clinical validations like the doctor point of view and some other attributes. Now the second model is MedPalm. Such model is strong from answering but not open source, because it's not open source, it means a lot of money you give them for the subscription, and when you apply from the production point of view, it take too much money. And the third is Milama, excellent from text-based tasks, but it does not support for images. And from the radiology and CT scan point of view, we also need for the images interpretations. And the other is the PalyGemma. It's also a model of collaboration of Google, but it's good for image captioning, just for image captioning, and limited for text abilities. That's why the comparison is that you go to the Google and other search engine, and you compare that. You also go to the MedGemma homepage, and you also explore that the other features and other things regarding the MedGemma. Now the point of view is that how we implement in short prototype, how we interpret and embed such model in a short prototype from our purposes. Now I made a sequence diagram how we implement that. You see that first of all the user browser. First step is that you upload your image of our application. In such sequence diagram, we use the Streamlit. You also use some other GUIs like Gakio, like React and Next.js. But Streamlit is also a powerful GUI specifically for the machine learning models. First step is that we load the image and upload the image. After that, the image through Streamlit, your connect established from some AI cloud point of view, because this prototype is designed from point of view of cloud. In such, we use the Vertex AI endpoint. Endpoint means a cloud give you a node for the interpretation, and the model is also deployed on that. But you also deploy such model in locally, but you need resources. Inshallah, when our machines are in a full functional form and we have access that, we also build some LLM models and running example on that, because things are state of the art thing, and these are the modern technologies, and eventually we move forward such technologies. Now, after establishing the connection from our endpoint render means the upload the image or on the endpoint, and after uploading the endpoint, you see that at the point number 4, our image is scanned at, and after scanning, we submit a chat prompt, just like that. We upload a Alzheimer image, and we give the prompt the answer, diagnose it, the image, and the image send the query to send the image and plus the prompt query to the Vertex AI, the model which is deployed. And after the model, the MedGemma is deployed. You see that the MedGemma is last line. And after the analysis, the generated analysis report send back the response to the Streamlit server, and Streamlit server provide the result from the user browser, because these are the 10 steps. And in a real-time scenario, we also build such application in such a scenario, but some other things are also including that, like APIs and tools, some complication regarding to our need. But this is a simple thing of every model when we build. This is simple scenario, and this scenario covers both thing, image plus uh, the textual prompt. Now
Azam, I
this
have a
is
question for you. Um, Sorry to cut you.
yeah,
So this is exactly the same architecture that we are following, in the sense that our first diagnostic, Azam's diagnostic report that we've generated, the PDF, that is essentially also based on this
yeah, yeah,
scientific background, right? Okay, perfect.
yeah,
So
yeah,
at
yeah.
the end of the call, maybe let's just quickly run through our diagnostic report. I've just sent it in the group right now as well, although I know everyone has it. But at the end of the call, maybe we can just quickly go through it in a couple of minutes, okay?
Okay, now in the practical point of view, we have a practical demonstration. You see that we have also implement MedGemma in a Hugging Faces. The Hugging Faces is a very useful site regarding from LLM and other models. As you go to the Hugging Faces, there are also available the spaces where you upload your model and also implement some other models. You run that. Somebody implement such model is that, and I run such the model. First of all, I am giving a image. I am selecting a image from overside. I am selecting a image, and I am selecting a very moderate level dementia image. And after I upload the image, I also give some additional information. You see that I give the prompt, you are helpful medical expert, explain and diagnose the image, explain and diagnose the, the given. After that, we have some token points. How much token? These are the technical things. When you give more tokens, the model give more efficiently, but more computing power and other thing regarding the LLM point of view. Now I just go to the interpret that. After you see that the interpretation, the model successfully go to the GPU and the GPU interpret that. You see that the interpretation is that as you see that okay, I can help you to understand what the image represent based on the first of all if it gives you the image nature. This is T1 weighted axial MRI magnetic diagnostic image scan from human brain. It does that in. Let's break down that overall shape. The image display the critical core section view of the image, and
Can you
after
open
that
the doors?
and after
Sorry, sorry,
that
go on.
the gray matter, the white matter, and other things, and all the things regarding to the interpretation of the models are giving to that. Now I am selecting some other example. This is the brain example, and I am selecting some example like uh, wait a minute, demo. Now I am giving some example of some chest X-ray, and I am uploading that. The and I also give the example train and diagnose the image. Now the model giving the model, and after giving the model, you see that. Wait a minute, I think so. Waiting. The model take because this is wait. I am refresh such model. Now I upload the image. I upload the X-ray image and give him the just give him the prompt, explain it. Now I am giving the task from the model, and you see that a model is in processing view because this model is free of cost, loading not Vertex AI, loading the backend, and sometimes the backend is busy, and such a problem is that the interpretation of that's why when we use the locally we have not some such type of issue, and similarly with when we use a paid service such issues are no. Now I move forward that such interpretation is also locally. I am some result are going to our machines, our office machines. uh, you see that I am uploading such X-ray, and after the interpretation of the X-ray, it gives you The interpretation of the X-ray is that the image appear in standard posture, chest X-ray, and the lungs are well expanded, and there are no visible sign of acute pathology, and also give you the heart size, the lungs information, the bones, the soft tissue, and after that, they concluded that based on the single image, there are no obvious acute abnormalities. However, the definite diagnosis cannot be made slowly on this X-ray. Further evaluation and the last, this is a preliminary interpretation because this when we diagnose the AI, such explanation is also giving in the medical point of view. And similarly, after we are giving some other image, such image, and the X-ray is also a normal adult X-ray, and it's no obvious sign of this is also a normal image. And similarly, some other examples like the MedGemma, the phenomena like question like the first bacterial and phenomenal bacteria question, and similarly the other thing, the clinical point of view, such all things are explained by the MedGemma. Now I move forward. See that the model in backend is not providing result because some other things at the backend. You see that the
Azam, before you move forward, I just quickly wanted to connect this to our diagnostic Alzheimer's diagnostic report. So after you explain this section, can we just quickly go through that report as well? Because that's also utilizing MedGemma, yes?
yeah, the report which are uploading in the net. Wait a
No,
minute.
I just sent it to you. So if you have WhatsApp open,
Oh yeah, yeah.
I just
No,
sent it
no.
in
I
the.
have a live also available
Oh,
in live.
you have the live.
Oh yeah, yeah,
Okay, okay. As you are comfortable, we can see this as well.
yeah, yeah. This is live report regarding the diagnostic of the diagnosis of Alzheimer. In such case, we uploaded some MRIs and fMRIs, and after the diagnosis, we concluded some report. You see that the clinical summary and diagnosis of portable Alzheimer disease. And after the preliminary diagnosis, Alzheimer disease is moderate stage. It provides you after diagnosis the different slices of the MRI and fMRI. It diagnoses the stage of the Alzheimer, because if you have different stages like mild stage, not dementia stage, and the moderate dementia stage, low mild dementia stage. These are the stages of the dementia, but the moderate state is that you have a dementia at the top level. And after that, the key imaging finding, some other interpretation by the over LLM by using the MedGem and other things. You see that the MRI brain analysis, the labeling, the diagram of three views of the MRI. First is axial view, and all the views we are using T1 weighted image because the results of T1 weighted images are more clear as result to T2 weighted, because T2 weighted needs high resolution and other things. And now the other is the
So
brain.
Azam, basically the system does all this, right? So this is the pre-processing stuff like the
Yeah,
segmentation and everything. So the
yeah,
system
yeah,
does everything, right?
yeah. The system does
But if
through.
but if but if someone wants to directly go to MedGemma, they will not be able to do all this because you have first trained your model and
Yeah,
then
yeah,
extracted what you needed from MedGemma. Yes.
yeah. Because MedGemma gives you the disease level at your the training of the MedGemma capability. But these reports are designed specifically for different analysis and different things, and we utilize also MedGemma in such reports according to our need. But in such level, we also use some part from Gemini Pro and like Rook. also interpret the disease. They have also capability to interpret the disease models. And you see that these are the brain tissue segmentation analysis. And after that, we are the attention map. Basically, this is a purely model designed by using some MNI 152 model templates and utilizing that, uh, diagnose that the attention map and generate some such type of reports, and other analysis that the graphical representation of the slices of different point of view, 0 to 25 slices, and that can junk 35 to 61 slices, and the other junk is that 17 to, basically these are all the things which we are concluding for statistical analysis for the representation or an orientation of over slices and some results. And you see that these things are generated by LLM. Things are generated through LLM, and these things are not a static pattern. These things are changed according to the patterns and according to the training of the model. And these are the values are the same, but the English wording may be different for different point of view. And sometime when we regenerate some reports, some things are called rather than the values, the other things are changed, like the flexibility of the LLM. And after that, the special intention localization report, and then we move forward. And this is basically a gradient cam analysis. And I also want Dr. Shah students to make more attention on the such like of graphs like heat map and attention maps and segmentations, because these are the real time analysis. These are the analysis which need some sort of programming and some sort of other thing. You see that the model picks some images from different point of view, some axial view, some sagittal view, and some corneal view, and point out and highlight the such section. And these coloring are also a uh, symptom by symptom. Brain neurology has more than 150 image color labeling, which are also available in the internet, and you use such color from your gradient cam in understanding of that. And after that, the explanation AI, we use the explanation AI, and explanation AI explain that what is the meaning of red color and the orange region, what is the meaning of yellow and green region, and what is the meaning of blue and purple region. These are also interpreted by explanation AI with the help of LLM. And also the hippocampus focus, the trubal lobe emphasizes and other things. And these are the intensity graph of the intensity. The reddish is the high attention, the blue is the lowest level. And after that, we also make a report of 3D gradient plus. This is also a algorithm representation of the Alzheimer. And after that, we use the quantitative brain volume analysis, because it judged that the volumes in the case of MLs and being the values. And after that, the status of it, that the 8th level is fear status, 15 level more reduced, severely reduced, and these things are the things which are the people who know about the brain neurology must understand that. And this is the clinical, and this report is that the clinical report, because some clinical tests, which Ahmad are also told you that some clinical data, like some assessment tools of make some tests, cognitive tests of the patients and their results. You see that the MMSE is other assessment tool test, and the patient got a results of 16. These are the built-in results which we add in the report through the CVC file and some other way. Yes, so some data entry, backend report, and basically such other analysis, a trophy Meyer analysis, and these analyses after that, the interpretation in the hippocampus, neuropathological correlations, and at the last we conclude a graph format brain entropy score analysis, because the brain entropy also provide the symptoms, the clear symptoms of the Alzheimer disease. You see that the cortical atrophy score, hippocampal atrophy score, hippocampal atrophy right, left, both score, and the anterior and posterior score, white matter also mention the Alzheimer's, and also the interpretation with the help of LLM and these things. And at the last, the values of the scores and some other things that specifically the nautical trophy scores, because the nautical trophy also give you some information about the Alzheimer and after the interpretation, because this is too much uh, anybody
So, guys,
regarding
I'm going
the.
to add something over here. So, guys, I want you to think of it from this perspective that the doctor will be able in a position to upload a fMRI and then generate this report. And this report is going to get better. We're going to add more things. Now we are going to collaborate with neurologists, so they're going to tell us what more they need, what's going to help them get a better diagnosis. So this report will evolve. But I want you to understand that it makes life very, very easy for the doctor if they have this option of uploading a fMRI and then the system is in place, the NCAI product, which does everything. It does the pre-processing, it does the interpretation, it does the graphs, it does the charts, it gives you everything. And it makes it very, very easy for the doctor to move forward with the diagnosis. Not only that, but they can also incorporate historical patient data that they already have, as Azam said. And then they can also have a conversation with this result and say and question it. Okay, why is the hippocampal thickness decreasing so quickly over the past 6 months, for example? And then the system will generate an answer and tell them, and the system will take into account everything, the entire historical patient data for that specific patient. So this is something that is evolving. And a lot of people ask me, they think, oh, so from a general perspective, people have this notion about AI that, you know what, people just make a dashboard and at the back end, they've got ChatGPT or something or some model. And then you go and input your data into that model, into that user interface in the front end. And at the back end, ChatGPT does everything and it gives you this. That is not the case. If you go and upload a fMRI to MedGemma or to ChatGPT or to DeepSeek or anything, it will not give you in this level of analysis at all. It will just give you a vague answer. So this is the model that we've trained. We've trained it on data. Azam has taken different good parts of it and put them together. And now our model is generating this. So we are using different medical LLMs. It's not just MedGemma. We're also using agentic AI, so RAG, the retrieval augmentation generation. So what it does is based on the image that we are uploading, it selects first the best medical literature out there, and then it fetches that information. Now it's up to the RAG to decide whether it wants to use MedGemma or some of the other medical LLMs that we use. So it is a complicated process when you make it. It's not easy. It's not as easy as just, uploading it to a website and then getting a result. There's no such product out there which gives you this level of analysis from an Alzheimer's perspective for fMRI or MRI. So this is something that you have to understand, and we truly appreciate Azam's effort in this progress that he has made. I think he has done very, very well, mashallah, and the neurologist at King Faisal Specialist Hospital and Research Center really liked the report, got a very good positive review from them. And inshallah, the research and collaboration agreement is with the legal department. They're reviewing it. Inshallah, it will go through. So you'll be seeing good things. And once that happens, inshallah, I will get all your students, especially Dr. Schwag students as well, and the other students who like to join us. I will get them to come and visit King Faisal Hospital. You're going to interact with the radiologists and the neurologists over there, and that is how you will gain experience in this field. So, inshallah, it will be good. Azam, thank you for walking us through the report. If you have anything else left in the presentation, please finish
Yeah,
it.
yeah,
Thank you.
yeah. Now, the last part of is that recently the Google provide you the anti-gravity, the agent-driven AID. Basically, normally we are using the visual source code. As you see that this is a visual source code. Similar ID provided by the Google is a agentic point of view, because this is not agentic, but add copy such like theme, because majority of the students, approximately 99 more than 90% user use the visual source code, the Visual Studio from the coding point of view. Now the anti-gravity is similar to that, but the plus point is that it provides you the agent-driven ID. How it's work like that? In normally you have the traditional I like the Visual Source Code. You have editor and you upload the file and write the code and compile the code and debug the code. But in case of the Google Anti-Gravity, you use different agents on different point work. One agent is work from planning, other is from coding point of view, the check the codes, and other, and the agent manager manage all such agents. User interact with the agent manager, and agent manager give the task from the different agents like the planning agents, coding agents, the terminal agent, and the browser. These like the schema from the anti-gravity, and I must suggest from the medical students to use such ID, because that ID does not need the coding stuff. It just needs the giving the prompt, and prompt engineering also some good exercises of prompt engineering is available in the net, and I also shared on the repo of the narrow cognitive AI, which you also use that, and you see that the first welcome window of the Google Anti-Gravity is that you have the agents, and you have the start conversation area which you put your prompt, and your prompt making a application for you. Now you see that we have anti-gravity, the major area where your conversation is going on, and the workspace where your folder and all things are automatically create that. Now we also install the MedGemma and the machine for your point of view, and some one demo exercise, because I think though it is a futuristic ID. One ID is also available in the market, Cursor, but I feel that it's a open source and free of cost, and because the Cursor give you the $20 and in the beginner level, and after that when you are to some experiencing it, the subscription is aroundly $100 per month. But the anti-gravity is similar that free of cost, and you see that we install the anti-gravity on Windows 10, and first of all we give the path where we install the anti-gravity. Now we move forward, we name that the anti-gravity, and after that we also select that create a desktop icon, and the some options are already taken that, and after that we install that. After the installation we make a demo, a simple application, and how the application is built on. Now the install the application. Now I am making a folder of test MedGemma. It takes just like 1 or 2 minutes, and the all the things are installed in my machine. Now we have a tutorial also from the people point of view. Just a minute. Um,
While this loads, guys, I'd just like to say something. So I know Dr. Schwag students are here. Now I know some of you were with Dr. Schwag on this conference that you guys attended, and I know you've presented papers over there as well. Not exactly sure on the information. But what I would like you to do is in our WhatsApp group, please share your achievements over there individually, what your experience was, and if you have any pictures from the event or anything. I just want the other students to also get a hang of what's going on and what you guys are doing. So it's interesting. Remember that some of our students in the WhatsApp group are from backgrounds which are not from a neuro background or not from an AI background, and some of them are very young, like Zayan, for example. She's only 17 years old. So she gets they're very interested in this sort of stuff, and these are events and conferences that they have not seen previously. So please do share in the group, and it will be nice. I think everyone will enjoy it. Azam, back to you.
So now the MedGemma I install in my machine and I load the anti-gravity. I think so. The loading that. Now I allow the access from it, giving the access, and it's loading on my machine. Now the it's installed. That first of all, you have the screen that when you install the anti-gravity and you move to next. And the if you have some code configuration from Visual Source Code, you select such option. If you are not a professional, you go such option, start fresh, and after that you select the layout. There are different layout. Normally we are using the dark layout. You also use according to your requirement. And after that, we recommend that we have different type of development modes, but we select the agent assisted development mode. We have agent driven development also mode, and this is the some higher level mode. And we recommend that, and Google also recommend that you use agentic assisted development mode. And terminal execution policy is auto, and your review policy is also a auto. And agent decide JavaScript is also your default browser is your allowed default browser is basically my default browser is Google Chrome. And after next that we have some other editor information. We installed that the normal thing, Vim is other key binding thing, and we also include some 7 extensions which are also the Gentic extension, popular extensions which are you required by the ID. We also installed that. And next we sign in. Basically it give you the way where you sign in your I am using my other account. uh, Basically I have 2 accounts and I am using my Gmail account. And I am giving my password. No, now it's take a verification on my mobile. And after that successfully authenticate that. I continue my recent profile and wait a minute. And you see that the anti-gravity also integrate my account. And now I open my anti-gravity and the anti-gravity is now that. After that we now this is basically the first window of anti-gravity of my terminal. You see that in right of that you have a different model. You see, you select basically they are providing you the Gemini 3 Pro, Gemini 3 Low, Cloudy, and Cloudy Sonnet. These are also a well good model, and these models are supported by the anti-gravity. In real way, the Cloudy Sonnet is not free of cost, but in anti-gravity, because the anti-gravity and the entropic is a collaborative partner. That's why the anti-gravity use the free of cost such model, and I am uses the Google 3 Pro. And you see that we have a folder which we make our test demo. I am creating a folder on my drive, and is named as GEMMA, Test MedGemma, and I am giving such folder. And after that, we have I also bind this folder from GitHub, and you see that um, it's loading the model now. Basically, this is the prompt screen where I get you how which application I have made. Now I write a prompt. I write a to do app program in Next.js and uh, shared UI and Tailwind. Now I am giving the command from to build a application for me through agentic way. You see that the application is generating now, and the MedGemma and the anti-gravity is going to writing a code automatically through the with the help of agentic AI. And you that it is working now. At such point, if anyone have a question,
So, Azam, I have a question about this, about anti-gravity. So, what this does is it helps you build models.
basically it gives you all things. It gives you models, and if also give you craft. Uh, um, you cannot see that it give you provide you some prototypes, and like some chatbot like applications, some websites, and some GUIs, and some backend and some front end, and just like click and you see that we have the all the options, and I think that I am now the all the options. The planning of the task is making by the agentic AI, and now the implementation task plan is also going to move on. You see that first task is made that how the design is such thing, because they are doing all of
Mm,
thing where you're doing just like the commands and manual way. First of all, you see that
mm,
for preparing the app, first of all, each initialize the project from the Next.js, and then configure the some UI things, and then design, create a layout and theme and input component, and a list component, item component, and at the end some state management functionality like add of to-do list, delete of to-do list, persistence, and then at the end verify. And you see that at the right hand, basically such area is called the playground area. The playground area, all the things are giving you in the further way. I accept something. It's giving me the command that you accept it, you're not accepted, I accept it because it's running that, and all the things are in a click and plug and way. In real time when you build an application, you have the non-person. If I am programmer and I am making such application, I take approximately to 3 to 4 hours and make of mistakes during my writing of code. But in such case, you just give just a 5 to 10 minutes and your application is ready, and you just tune down your application according to your need. All the architecture is built by the anti-gravity. This is the main thing.
that's amazing. That's amazing, Azam. I think this is a very, very good application. This is very, very helpful, especially for
I
students
also,
who have a
uh,
non-programming background.
yeah. I also suggest such students because many of students make too much problem for making a simple GUI. In case if I am write a prompt and I am just calling such a GUI that make a GUI from a simple machine learning model for upload an image, and in a backend make some model. That's application makes such thing in just like 5 to 10 minutes, and I am just giving some right path and other things, and I believe that after the 30 minutes you have a full applicable application in your web. This is basically
Thank you, Azam. Yep,
बस
this is very helpful.
या बस
I, I,
इट्स टेक
I think we've exhausted our time limit for today. We've passed the 1 hour.
या
So I think let's catch up next time if anything is left, and we can start from there next time
ओके
around. Guys, again, we will be in touch with you guys throughout the holidays as well. And as soon as the lab is running, inshallah, next weekend, I will let you guys know so that you guys can then contact Azam and then get remote access and then start. That's when the real fun will begin. Yes, Azam?
या ओके
Inshallah,
नो
inshallah. Okay,
इंशाल्लाह नो
guys, have a good weekend. Yes, Azam.
I upload all the things and some tutorials for the working of the both the MedGemma and also for the working on anti-gravity and some tutorial information and some other useful links. And inshallah, I suggest all the citizen and advise to use such things because these are the state of the art things. And recently, many people are also beginners of such applications and we are also a beginners. And I believe that if you take some 1 or 2 weeks, you will be perfect on such tools.
Perfect,
Now,
perfect. Thank you, Azam. Thank you for your input and help. And thank you for everyone who attended today, and for those of you who will go through our training session. If you have any questions, please do let us know. We're happy to answer them. And perfect. Good night, and have a safe weekend. Have fun, and inshallah, we will be in touch soon. Thank you. Thank you very much.
okay, Allah Hafiz.
Allah Hafiz.